Chapter 1, Relations and Functions, class number 2. A function f of x is equal to y is called a 1, 1 or injective function if the images of distinct elements of x under f are distinct. In other words, for every element x1 in the domain, there is a corresponding only one element x2 in range. A function f of x is equal to y is called a onto or surjective function if every element of set y, which is domain, is the image of some element of set x or range. In other words, for element x which belongs to the range, there exists an element x in the domain such that f of x is equal to y. F of x is equal to y is an onto function if and only if range of f is equal to y. F of x is equal to y is a bijective function if it is both 1, 1 and on 2. Let A be the set of all 50 students of a class. Let f of A equals to n be a function defined by f of x equals the roll number of a student. X show that f is 1, 1 but not an onto function. Solution. No two students of one class will have the same roll number. Hence, there is a one-to-one mapping amongst the students of a class, which is the domain, and their roll number, which is the range. Therefore, f is a one-to-one function. The numbers 51 and above belongs to y, but they are not the image of any element of x. The reason being x has roll numbers from 1 to 50. Hence, there are elements of y which does not have an image in x. Hence, it can be said that x is not onto. The function fn maps to n where f of x is equal to 2x. Show that it is a 1, 1 but not onto function. For every f of x1 which is equal to f of x2, we have 2x1 is equal to 2x2 or x1 equals x2, which in turn proves that if f of x1 is equal to f of x2, then x1 has to be equal to x2. This proves that f is 1 to 1. Fx is not onto function because only even numbers in y will have a pre-image in x. The odd numbers in y will not have any pre-image in x as f of x is always even. Prove that the function fr maps to r where f of x equals 2x is both 1, 1 and onto fx is 1, 1 as proved in the previous example. In this case, fx is also onto function as all elements of y will have a pre-image in x. This example is different from the previous example because x and y belongs to real numbers in this example, whereas in the previous example, x and y belong to natural numbers. Show that the function f of r maps to r defined as f of x equals x squared is neither 1, 1 or onto function. A negative number, say minus 1 and 1 belonging to x, will have the same image 1 in y. A square of minus 1 and 1 is 1. Hence, the function is not 1, 1. Function is not onto as the negative numbers in the codomain y will not have any pre-image in the domain x as only square, and hence positive numbers will be pre-images. If f of x is equal to x plus 1 when x is odd and x minus 1 when x is even, prove that f is both 1, 1 and onto. Domain and codomain of f are set of natural numbers. Let f of x1 is equal to f of x2. if x1 is odd and x2 is even, then according to the function x1 plus 1 is equal to x2 minus 1, which in turn implies x2 minus x1 is equal to 2. Now this is not possible as our original assumption was x1 is odd and x2 is even. Therefore, x1 and x2 must be both odd or both even. Consider they are both odd. Then f of x1 equals to f of x2 equates to x1 being equal to x2. A similar logic can be applied if both x1 and x2 are considered as even. Hence, function is 1, 1. Any odd number, say 2r plus 1 in the codomain, is the image of 2r plus 2 in the domain. And any even number 2r in the codomain is the image of 2r minus 1 in the domain. Hence, all the elements of codomain are covered whether they are even or odd. And therefore, f is onto function. A function fr maps to R is defined by f of x equals 1 by x. Show that it is an 1 1 and onto function. Will the result be still true if the domain R is replaced by n, while the codomain remains same as R? If f of x1 is equal to f of x2, we have 1 by x1 equals to 1 by x2, which in turn implies x1 is equal to x2. Hence, f is 1 1 function. Consider any element y in the codomain. The pre-image of y in the domain is 1 by x. Since f of 1 by x is equal to y, all the elements of codomain are covered, and hence function is onto function. A function fr maps to R is defined by f of x equals 1 by x. Show that it is an 1 1 and onto function. Will the result be still true if the domain R is replaced by n, while the codomain remains same as R? Once we replace the domain from R to n, the function still remains 1 1 as all natural numbers will have a reciprocal which will be a real number. In the case, the reciprocal of the natural number is in the codomain. F is not an onto function. Consider a natural number, say 2, in the codomain. Its pre-image is 1 by 2, which will not be present in domain, because domain is a set of natural numbers only. Check the injectivity and surjectivity of the function f of x equals x square. Here both domain and codomain is set of natural numbers. Injective means 1 1 function and surjective means onto function. To check for injectivity, consider f of x1 is equal to f of x2. This implies x1 square is equal to x2 square, or x1 equals plus or minus of x2. Since x1, x2 are both natural numbers, we can ignore the negative sign, and hence x1 equals x2, which in turn proves f is onto function or injective. F is not surjective. This is because if we take domain values as say 1, 2, 3, the range will be square numbers 2, 4, 9. Those natural numbers in codomain, which is not a square number, will have no pre-images in domain, and hence f will not be a surjective function. Check the injectivity and surjectivity of the function f of x equals x square. Here both domain and codomain are set of integers. Is f injective? Like in the previous example, equating f of x1 and f of x2, we get x1 is equal to plus or minus of x2. But in this case, negative sign cannot be rejected as x1. x2 belongs to set of integers z. Hence, f is not 1 function. Like in the previous example, f is not surjective because the range of f comprises only square numbers. Hence, a number like say minus 2 will have no preimage in domain. Check the injectivity and surjectivity of the function f of x equals x cube. Here, both domain and codomain are set of integers. Is f injective? Let f of x1 and f of x2 be such that x1 and x2 belongs to domain. If f of x1 and f of x2 are equal, it implies x1 cube equals x2 cube or x1 equals x2, which in turn indicates that f is injective. F is not surjective, as range of f only consists of cubes of integers. All non-cubes present in the codomain does not have any pre-image in the domain. Prove that the greatest integer function where both domain and codomain is in R is neither 1, 1 or onto. As an example, let's take x1 equal to 2.5 and x2 equal to 2.8, where both x1 and x2 belong to domain. F of x1 and f of x2 will be both equal to 2, where f is the greatest integer function, but x1 and x2 are not equal in this case, hence f is not 1, 1. F is not onto as the range of f comprises of only integers, whereas the codomain belongs to R. Since range and codomain are not equal, f is not onto. Show that the given function, which is called a signum function, is neither 1, 1 or onto. If x1 equals 2 and x2 equals 3, f of x1 and f of x2 is equal to 1. F of x1 and f of x2 are equal to each other, whereas x1 and x2 are different. Hence, this is not 1, 1 function. The range of f is only 1, 0, and minus 1, whereas domain is in R. Therefore, f is not an onto function either. In each of the given functions whose domain and codomain is in R, determine whether the functions are 1, 1, onto, or bijective. The function 3 minus 4x is a 1, 1 function. The reason being when f of x1 is equal to f of x2, the corresponding elements in domain, that is x1 and x2, are also equal. To check for surjectivity, consider an element, let us say y in the domain. According to the given function, y will be equal to 3 minus 4x. Once we convert x and write in terms of y, we get determine whether the function f of x equals 3 minus 4x is 1, 1, onto or bijective. In the previous slide, we calculated the value of element x in the domain in terms of y, where y is the corresponding element of x in codomain. As shown in the slide, f of this element x equates to y, and hence the supposition is correct, which leads us to the conclusion that f is onto and bijective. In the second part of the question, determine whether f of x equals to 1 plus x square is 1, 1, onto, or bijective. F maps to set of real numbers. Equating f of x1 and f of x2 does not necessarily mean x1 equals x2, as x1 can be equal to plus or minus x2. Hence, f cannot be a 1-1 function. F cannot be an onto function either. This is because range of f is always greater than 0 as x square. Plus 1 is always greater than 0. Negative numbers in codomain will not have any preimage in the domain, and hence f is not an onto function. If f of n equals n plus 1 by 2 if n is odd and n by 2 if n is even, check whether the function is 1 1, onto, or bijective. The function lies in set of natural numbers. To examine whether the function is onto, consider two natural numbers 3 and 4. F of 3 is 2, whereas f of 4 is also 2. Since f of x1 and f of x2 does not equate to x1 being equal to x2, we can say that the function is not 1 1. As shown in the slide, if we put n equals 1, 3, 5, and eventually set of all odd numbers, f of n is a set of all natural numbers, which implies range of the function and codomain of the function are equal. This is a condition which satisfies for the function to be onto. If f of n equals n plus 1 by 2 if n is odd and n by 2 if n is even, check whether the function is 1 1, onto, or bijective. The function lies in set of natural numbers. Similar to the logic applied in previous slide, if we put n equals 2, 4, 6, and eventually set of all even numbers, f of n is a set of all natural numbers, which again denotes that range of this function and codomain are equal. Based on these two assertions, we can say f is onto function. Consider the function f of a maps to be defined by f of x equals x minus 2 divided by x minus 3. Determine whether f is 1 1, onto, or bijective. Equating f of x1 and f of x2, we can deduce that x1 is equal to x2. This leads us to the conclusion that every f of x1 in the range maps to a unique element x1 in domain, which makes the function a 1 1 function. Consider the function f of a maps to be defined by f of x equals x minus 2 divided by x minus 3. Determine whether f is 1 1, onto, or bijective. To check whether the function is onto, we consider an element y in the range and express x in terms of y. For every y in codomain B, there exists a preimage x such that x equals 3y minus 2 by y minus 1. Now, rewriting f of x and replacing x by y, we finally deduce f of x equals y. This proves that the function is onto function. End of class 2 on relations and functions.